Now you must be excited for our new experiment. Let's grab the car again. This car. Let me line it up in the starting line. I'll give it a little push and record where it stopped. Now, what if I gave it a harder push? Oh, it's going to fall. Actually, it reached till the end. Now, what do we notice? We notice that when I gave the car a little push, it moved to this. It reached to this point only. But when I gave it a harder push, it went all the way through the end of the table. So which force did I make for the car in order to move? I gave it a push. So a push is a kind of force. Yes? We conclude that more force was needed to make the car move farther. We're talking about forces, which is lesson 2 from chapter 11. And we're going to cover first the push and pull forces. Let's open to page 368. Now, what makes things move? Objects cannot start to move on their own. You have to use a push or a pull to put something in motion. When you play soccer, you kick the ball to move it across the field. Your kick is a push. If you do not kick the ball, it will stay in the same place. Let's check out this photo here. The girl is trying to kick the ball. So, in order for the ball to move, the girl has to kick it. So, which force does the girl give the ball in order to move or to go higher? She gives it a push. The kick is like the push here. Now, what do you think if the girl gives the ball a larger push? The ball is going to get lower or higher? Of course, higher. So in order for the ball to go higher, the girl must give it a larger push, a harder push, or a harder kick. Okay? A stronger kick will make an object move farther. Let's go to the other page. You see the ball is getting higher here. A push or pull is called a force. If you push something, it will move away from you. If you pull it, it will move closer to you. Like here, if I push the car, I'm moving it away from me. If I'm pulling it, I'm moving it closer to me, okay? A kick is a kind of push. Opening a drawer is a kind of pull. So in order to open the drawer to take new clothes or clean clothes, we have to pull the drawer. If we want to close the drawer, we have to push it. Sorry. You can move different objects with different amounts of force. Like here, for example, in this photo, we see a guy and he's shopping. So he's trying to move the cart. In which way? Forward. So which force is he using? He's using the pushing force. What is making the cart move? The push force. Here in this photo, we see children and they're playing with the rope. What are they doing with the rope? They are tugging the rope. So which force are they using here? Of course, the pulling force. So let's see the photograph of children and they are tugging the rope. If one of the teams let go the rope, what do you think will happen to the other team? Let's say this team let go the rope. The other team is going to keep on pulling until they fall. Yes. So what do you think? Why do we need forces in order to move things? Yes? Now, what are some forces? When you let go of a ball, it falls. Let me show you this seashell. Okay, I'm going to throw it. Will it fall or stay in the air? Let's see. It fell. Let me try using a tissue. Okay, but because it's windy, actually it's going to fly. Oh, okay. It fell also. So, which force here is being used? What is making the objects fall back to the ground? It is gravity. Gravity is a force that pulls down on everything on Earth. When you jump up in the air, gravity pulls you back down to the ground. Gravity pulls on objects through solids, liquids, and gases. The amount of force that pulls something down towards Earth is called its weight. So when I let go the seashell, it fell quickly. It fell actually faster than a tissue. Yes, that's because a seashell has more mass or more weight than a tissue. The tissue is lighter than the seashell. That's why it took a longer time in order to fall. Let's take a look at, you remember this ball that the girl was kicking in the other page? Yeah, now it's going to fall back to the grass, to the ground here. Let's check this dog here. Why is the ball falling? Why do you think the ball falls down to the ground? Because of gravity. What do you think will happen to the dog here, that is the dog that is jumping? Also, it's going to fall down to the ground because of gravity. Now let's go to page 371. When you skate, you drag a rubber stopper on the ground to stop. See, the girl here is skating. This is a roller skates. And what if the girl wants to stop? She needs something to stop because she might be hitting a wall or anything. So she needs to stop. In the roller skates, the rubber stopper in the back, she's going to rub it to the ground so that it stops. Yes? Let me show you again the car that I was moving. Okay, you see how it's moving in a good way. Now let me try moving the car on the grass. Oh my god, it's harder. And why is that? Why do you think is this happening? It's because of a force called friction. Okay? The dragging causes friction. So the rubber stopper here in the skate causes friction. Friction is a force that slows down moving things. Friction happens when two things rub together. There's usually more friction on rough surfaces than on smooth ones. Here the car was moving smoothly because it was on a smooth surface. But when I tried to move it on the grass, it was a little bit harder. It is usually harder to push or pull something on a rough surface than on a smooth surface. Now, how do you think gravity and friction are alike? They are both forces, yes? Let us check the ball here. The ball falls down on the grass till it stops at this point. What makes the ball stop? Of course, the friction. the friction because it reached the grass. The grass actually, is it a smooth or a rough surface? It is a rough surface. That's why the ball stopped, because of friction. Now, let's go to page 372. We see a huge diagram. The 2 pages, 372, 373. Let's read here the text. How can forces change motion? You know that forces can change how things move. Forces can make things start moving, speed up, slow down, and stop. Forces can make things change direction too. In softball, the players use forces to change the direction of the ball. Here we have players. They're playing a softball. First, we have the pitcher, the batter, and the catcher. What is a pitcher? The pitcher uses a force to throw the ball toward the batter. So the pitcher is the person who throws the ball. So which kind of force is the pitcher using? The push. And when the ball reaches the batter is the person who holds the bat in order to hit the ball to another person. So the batter hits the ball with a push. Also, he uses a push. It changes direction and flies toward the outfield. So also we are using a push. Now at the end, the player in the outfield catches the ball and uses a force to stop its motion. He can also use a force to throw the ball to another player. So here, what do you think? How did the ball change its direction? First, the ball went this way to this way. Okay, it began with this way. Then it changed the direction to the other way. So it changed the direction how many times? Only once. Okay. Now, what do you think? The kinds of forces that are being used here? They are using actually push and pull, also friction. The pitcher is pushing the ball towards the batter. The batter is also pushing the ball towards the outfield, but the catcher catches the ball. When we try to catch a ball, we are pulling it to us. So the catcher is using the pull force, also stopping the ball from moving, which is friction. So he's using the pull and friction forces. Okay? So as a conclusion, forces are push, pull, friction, and gravity.